you got to be able to find the intersection points. Did you find those?
I think.
Okay.
So, I put. Oh wait, no. I didn't. I like got mixed up.
Did anyone get the intersection bounds?
Would be -3 to 3. Right?
It should be from -3 to 3. Right? Do I need to show how you do that?
Isn't it symmetrical?
Yeah, there's symmetry there. I mean, there's symmetry, but the bounds do go from -3 to 3, right?
Right.
You could go from 0 to 3 and multiply by 2 by symmetry, but that doesn't really matter to me. Which is the upper function?
12 minus x squared.
Minus x squared minus 6, right?
I have a question regarding
Sure.
how do you tell what's on top and what's on the bottom? It looks like in terms like this, like 3 dimensions. Like I don't know how to explain it. I'm a little confused.
Okay, so what is this? Isn't this positives?
Yeah.
And this is negatives.
Right.
So the more you go up, the more positive you become, correct?
Right.
So more positive is better than being more negative, right? I'd rather have $1 million than owe $1 million.
Yeah. Right.
So on top is looking at the perspective of the bigger positive number. So what's the bigger positive number? If we look at this point is bigger than this point, correct?
Correct.
So this would be on top of this.
Oh. Like this.
Yes.
Not like this. Not like one superimposed on
This is dy. Now we're talking about right to left. Further right is the bigger to the further left.
Okay.
Does that make sense?
Yeah.
Okay. And then this integral becomes something you guys can very easily handle, correct? So Daniel, tell me, what was it that confused you?
Honestly, the red line. Like I know
That's the cross-sectional slice. So meaning that's a slice at any one spot. And the only reason I put that slice there is so that I know what axis it crosses. What axis did it cross?
the y. Right?
X.
The x-axis, right?
Oh, because okay.
This is the x-axis. This is the y-axis, right? And since it crossed the x-axis, it's a dx. Had I gone this way, it would have crossed the y-axis.
Oh yeah, that makes sense. Oh, the actual graphs, yeah. That makes sense.
Okay? But if I went this way, we would run into an issue, would we not?
Yeah. Same graph.
Yeah, we can't have that. So, ... Now, you guys are becoming professionals, right? The area should be 72 units squared. Do you guys agree?
Yeah.
Any questions?
No.
Does anyone need to see it?
No, I did the math. It's just a concept.
Oh, don't worry.
Evan says yes, and I'm going to second that, just in case.
Who said yes? Oh, okay, got it.
That?
Sure. So I should get 12 minus x squared plus 6 dx, right? So that tells me I should get 18 minus 2x squared dx. Agreed? Shoulders jacked. Are you guys in agreement with me?
Yeah.
So that's just 18x minus 2x cubed over 3 evaluated from negative 3 to 3. Now, do I need to do the arithmetic for you too? I don't mind.
Sure, why not?
Yes, might as well. We're already here. Might as well park it.
What is that? 54?
Yeah.
Here, I'll look up my work. 54 minus, that's going to go away. That's 9, so that's 18. Minus, that's a negative 54. Plus 18. There's our symmetry, glorious, glorious symmetry. And so we're going to get 108 minus 36, which is 72 units squared. Okay, Ray, you said what? Where's what?
What is all over the place? So, hold on.
How I went from here to here?
Oh. Wait, no, I still don't.
This
Why?
one?
No, okay, because it went from 18 minus 2x squared to 18x minus 2x cubed. Divided by 3.
This went to this.
Yeah, how did you go from there to there?
From here to here?
Yeah.
Okay, what is the integral of a constant?
Add an X.
18x.
Oh my god.
X squared,
Yeah.
power rule, add a power, divide by that power. Right?
Scratch that.
You okay?
Yeah.
Okay. I thought you were like saying from here to here. I'm like, okay, I mean, I can explain that too if you'd like.
I mean, might as well.
Well, here it's easy, right? What happens is I have 3 cubed over 3, so that becomes 3 squared. 3 squared is 9. 2 times 9 is 18.
Cool.
And then distributing the negative, I get 108 minus 36, which is in fact 72.
Mm-hmm. I'm just gonna take a picture. Screw this. Cool. We're good.
Put it on the graph again. Oh, I have another question.
Right there?
Yeah.
Ask away.
So you know how the blue graph? That's if you tell which one's greater than the other, like on top of the other.
Okay, say that again, because you like faded out.
Referencing the blue and the black graph,
Okay?
it looks like the blue is on top of the black. Is that how you tell which one's higher than the other?
Okay. I don't understand how you're getting that. The black line, the black curve is this one, right?
Right. Yeah.
We're only looking at it, and I'll shade it so we can make this no doubter. We're only looking at this area that's shaded in. Where does blue look like it's on top of black?
It doesn't.
So I'm trying to understand what your question is. I want to understand.
Are you asking why is it 12 minus x squared first?
Well, I did the problem like that, but I just confused about which one's greater than the other.
Okay. So here's an easy way to figure it out, dude.
Ah,
Okay, when you're unsure,
hmm.
let's pick a value.
Yeah.
Okay, how about x is 0?
Oh, okay.
What's 12 minus 0?
12
What's 0 minus 6?
minus 6.
What's bigger, 12 or negative 6?
12. Oh,
You can kind of just look at, like, if it's in terms of x, you can kind of just look at whatever's higher on the y scale and lower, right?
Yes.
oh.
Yes. But if that confuses you, plug in x values. See which is the bigger number. That's going to be what we would consider to be on top. If we were doing it in terms
The
of
blue line was on top of the black one on the drawing.
are you upside down?
No, watch, if you zoom in very closely,
Microscopically, yeah.
see how the blue looks on top of the black? That's what I thought you meant by straight.
Blue is on top of the black.
Yeah,
See how the line?
They like overlap. So
Yeah.
it's like overlapping on the top.
Oh,
That's what I was
see. Here.
thinking the
Okay,
whole
let
time.
me fix that for you so you don't get confused, dude.
Yeah, so I was confused. It's like, how do you tell if they're superimposed?
Okay,
Like,
okay. I get what you're saying. You're thinking three-dimensional out. No,
Oh,
it's on the paper, two-dimension, up, down.
yeah. Oh, okay, that makes a lot of sense now.
Yeah.
Like,
No,
how do you tell if it's
we're not. You're not gonna go to Calc 3.
Oh.
Not till Calc 3 will we deal with the third dimension.
All right, I got it. No, thanks.
So okay.
Just to clarify, if it's sideways,
So this one you would have said blues on top.
Yeah.
No. Got you. And then here you're like, oh, clearly black's on top.
Yeah, that's what I was thinking.
Got it. No. Just, I'm like, what? Here, I almost need to do this for you now. Regardless of what the picture looks like. If it's dx, this is top, this would be bottom.
Yeah.
And even that's kind of untrue because if I did this, you'd be like, they're both on top.
Oh, I see. Okay, I got it. Thanks for
It's like elevator. Which one's higher up the floor if we're looking at two-dimensionally?
Yeah. Got it.
All right, God, I'm glad I was able to clarify that. I've never had someone think of it that way. That's
Oh.
that's cool. Maybe going forward I should just only use black. So there's this function and this function. This is f of x. This is g of x. And now you can't be like one's on top of the other. I was using color to differentiate the two functions.
Oh, all right, cool.
That-
I get the math. I got the same
that-
answer. I was just.
That's awesome. Yeah. We finally figured it out. All right, try this one. Try this one. And look, blues. Don't think of it that way.
Got it.
you use blue dots, so that means blue is no.
All right. So looking at this though, what is it? What are we going to integrate for, in terms of what variable?
Why?
Why?
It's y.
U1.
So now it's what's further to the right. And in this case, Gerardo, blue would have been on top.
Oh, cool.
Wait, how am I supposed to know?
Hold on, I got to fix this. This is supposed to be y squared.
What about the graph? Don't we need to know the x point? The x.
The x point.
The x.
You guys told me it was a dy, right? So that tells me I'm going this way with my slice, correct?
Mm-hmm.
So when I'm in terms of dy, my bounds need to go from where to where?
From left to right. Or
The bounds, if it's dy, it's the y
Up and
values.
down.
Yeah, it's the up and down for the y values. So where does that happen?
oh,
-2 to 2.
-2 to 2.
I see. Says the blind nerd. Okay, thank you.
Mm-hmm. Shall I?
Mm-hmm.
All right. All right, here we go. I'm going to mute you, Daniel. For some reason, you're echoing. All right, so here we go. So the integral should go from -2 to 2, correct? And the top function, when we look at this, should be the 4 plus y squared, right? Or in this case, the further right function. minus 2y squared dy. Agreed? So then this is going to give me the integral from -2 to 2 of 4 minus y squared dy. So I'll get 4y minus y cubed over 3. Actually, I'll show it so you guys can see it.
Wouldn't it be flipped with the signs? Like the -2 would go first? Like, cause it's like, wait, never mind. No, cause it's b minus a.
Dang it, what'd I do there? Oh, good. Yeah, it's b minus a, not a minus b. Agreed? Or that's 2/3. Correct? All right, how do you guys feel about this?
I feel good.
You good?
All right. I'm going to start recording and then see if you guys have any questions on like homework type stuff, okay?